They say reality is solid, that what you see, touch, and remember is the version that exists. But what if that certainty is just an illusion, a comforting lie told by your brain to survive something much stranger? Let's start with a question that feels almost dangerous to ask. What if you didn't make just one version of every choice you've ever made, but all of them? Quantum mechanics doesn't play by human logic. Down there, particles don't pick a side. They exist in multiple states at once, a phenomenon called superposition. Only when we observe them does one reality collapse into the one we see. But collapse is a tricky word, because according to one of the most controversial and now seriously reconsidered interpretations of quantum theory, the many worlds interpretation, nothing truly collapses. Every possible outcome happens. Every single one. You just happen to find yourself in this version. A version where you clicked on this video, not the next one, but in another universe, maybe a trillion light years away, maybe right next to this one, another you didn't. For decades, this sounded like science fiction. But what's shocking is that new quantum experiments are starting to back it up in subtle, eerie ways, suggesting the multiverse may not just be imagination, but structure. If that's true, it changes everything we think we know about decision, destiny, and even meaning itself. And the real proof? It might already be in our laboratories. So, how could infinite realities actually exist? Not as metaphor, but as physics. To understand that, we need to zoom into the smallest possible scale, the quantum level, where everything we call real begins to misbehave. Take the famous double-slit experiment. Fire a single electron at a barrier with two slits. If you don't watch it, it behaves like a wave, passing through both slits simultaneously, creating an interference pattern, as if it took multiple paths at once. But the moment you observe it, it stops being a wave. It chooses one slit, one path, one outcome. Observation seems to collapse the field of possibilities into a single storyline. That's the mystery. For years, scientists thought observation caused reality to choose. But Hugh Everett, a Princeton physicist in the 1950s, made a proposal that shattered that idea. What if the universe doesn't choose at all? What if every possibility actually happens, just in different branches of reality? In his view, when the electron hits the detector, the universe splits. One version where it went through the left slit, one where it went through the right. Both are equally real, but completely disconnected. And you, the observer, split with it. There's now one version of you seeing left, another seeing right. It's not just poetic, it's mathematical. The equations of quantum mechanics don't require collapse. They naturally allow all outcomes to coexist in parallel wave functions. Collapse was added later as a human patch to make sense of what we see. Everett's model removes the patch. Now here's where it gets stranger. Recent quantum computing research has begun to mimic this branching behavior. Not metaphorically, but operationally. Quantum computers exploit superposition and entanglement, performing calculations across countless parallel states at once. It's as if the machine briefly touches multiple realities to find its answer. Some physicists even suggest that quantum computation could be literal evidence of reality's branching, that when we run a quantum algorithm, we're borrowing computational power from those other worlds. If that's true, then every time you send a quantum bit spinning into superposition, you're not just encoding data. You're creating new slices of reality. And here's the paradox no one's fully solved. If every possible version of you already exists, every success, every failure, every decision, then what exactly does you mean anymore? Because the next experiment that tries to measure that might force the universe to split again. Let's tear the comfort blanket off. You think you live in one continuous reality, a single timeline, where choices lead to predictable outcomes, where yesterday builds into today, and today shapes tomorrow. But quantum mechanics laughs at that assumption, because if the many worlds idea is right, then the world doesn't move forward like a train on rails. It expands, explosively, endlessly, with every microscopic quantum event. Right now, as you're hearing this sentence, your world may already have fractured into countless others. One where you're listening slightly later. One where your screen glitched for a millisecond. One where you didn't press play at all. These aren't poetic exaggerations or digital metaphors. They're consequences of the equations that govern the universe at its most fundamental level. The math doesn't say possibilities disappear. It says they persist, diverging like roots of an infinite tree, each as real as the last, each holding a complete version of history. And that shatters one of the deepest illusions we carry, the idea of a single me. If every version of you exists somewhere, making different choices, then what binds you to this version? Is your consciousness anchored, locked to one line of existence? Or does it too spread across realities like light refracting through a crystal, glimpsing different angles of itself? Some interpretations of quantum mechanics go further. They propose that consciousness might actually participate in the branching, not just observing it, but influencing which version stabilizes. Others, more radically, suggest consciousness might even move between branches, not as fantasy, but as a byproduct of quantum coherence within biological systems, possibly within the brain itself. It sounds impossible, yet nature already allows similar miracles on the smallest scales. In quantum biology, scientists have discovered coherence at work inside living cells, in photosynthesis, in bird navigation, even in the way molecules transfer energy. Particles in these systems maintain many states at once, long enough to guide precise biological outcomes. So, if coherence can persist inside a plant or a migratory bird, why not inside the neurons of a conscious mind? What if awareness itself is a kind of quantum resonance, a vibration that tunes into one thread of existence at a time? That would mean your awareness isn't sitting still, watching one world collapse around it. It's surfing the wave of infinite possibilities, perceiving whichever branch remains internally consistent with its experience. Reality wouldn't be chosen by you. It would unfold through you, like a film projected frame by frame, each moment selecting itself because it fits the pattern of the last. It also flips how we think about probability. When you say, "There's a 50% chance I'll succeed," quantum physics might whisper back, "No, there's a 100% chance you'll succeed in one world, and a 100% chance you'll fail in another. You just happen to be here, in the version where one of those outcomes feels real. That changes everything, your sense of risk, of fate, of destiny. Because in the deeper fabric of reality, there is no gamble. Everything that can happen, does. Somewhere, somehow, each outcome unfolds completely, as if the universe refuses to delete any possible version of itself. And maybe that's the truest definition of existence. Not a single world, but an infinite expression of everything the universe is capable of becoming. You are one of those expressions, living out one possible thread of cosmic memory. But if every possibility is real somewhere, then the boundaries between somewhere and here start to blur. Could those infinite worlds ever interfere, even faintly, the way overlapping waves create interference patterns on water? Could two versions of you ever momentarily align, sharing a flicker of awareness across the veil? That question isn't science fiction anymore. Some physicists suspect that rare, unexplained quantum correlations, subtle deviations in randomness, might be hints of realities brushing against one another. If that's true, then every déjà vu, every inexplicable glitch, might not be coincidence at all. So here's the disturbing question that no physicist can yet answer with certainty. If every possibility is real somewhere, what happens when two of those realities start to overlap? Let's climb the ladder, step by step. Step 1. The math and theory behind the many worlds interpretation, MWI, of quantum mechanics. Back in the 1950s, Hugh Everett proposed that instead of the quantum wave function collapsing into one outcome when measured, the entire universe's wave function continues to evolve unitarily, meaning all possible outcomes happen, each in their own branch. In effect, the mathematics of quantum mechanics don't require collapse if you accept that each branch is real. That's the theoretical base. So the first rung, the formal consistency of MWI with quantum theory. Step 2. What about actual quantum behavior? Interference, superposition, entanglement. The classic double-slit experiment shows an electron or photon behaving like a wave and a particle, appearing to take both paths when unobserved, but only one when measured. This bizarre result underpins the notion of superposition, which MWI interprets as branching worlds, not collapse. More recently, researchers at Hiroshima University found that photons seem to go through two different paths, even when conditions were tightened, which reinforces that superposition persists in subtle ways we're still exploring. Thus, step 2. Quantum experiments are showing phenomena that fit the many outcomes logic. Step 3. Decoherence, isolation of branches, and the non-communication between branches. The reason we don't feel infinite versions of ourselves is that those branches decohere. They stop interfering with each other, becoming effectively independent. The theory of quantum decoherence supports the MWI by explaining how one branch appears classical while others diverge. Critically, many physicists point out that MWI and the more conventional collapse interpretations predict the same experimental results, which means step 3. So far, the evidence supports quantum mechanics broadly, but not uniquely MWI. For example, as one comment on Physics Stack Exchange puts it, there is not really any evidence for or against any interpretation of quantum mechanics. This is a key limitation. We have evidence of weird quantum behavior, but not direct proof that we are in infinite realities. Step 4. Emerging cosmological and indirect evidence for other universes that might align with infinite realities narratives. Here we move from lab scale to cosmic scale. Some scientists analyzing data from the cosmic microwave background, CMB, have proposed features like the cold spot, maybe the footprint of a collision between our universe and another bubble universe. If a multiverse of bubble universes exists, it gives context to the many worlds idea. Infinite realities could be not just quantum branches, but full universes. It doesn't confirm MWI, but widens the scaffold. And in 2023, academics published proofs showing that the many worlds framework must address issues of non-locality and probability rigorously if it's to be consistent in the Bell theorem sense. Thus the fourth rung, cosmological hints plus theoretical refinements pushing MWI's plausibility. If infinite realities exist, then existence itself stops being singular. It becomes statistical. You're not one consciousness moving through time. You're an overlapping probability field that constantly branches, sampling one thread of experience among endless others. That realization hits like vertigo. Because if every version of you exists, one who took the job, one who didn't, one who never met your closest friend, then personal meaning starts to dissolve. What's the significance of a choice if every outcome is played somewhere? The philosopher David Deutsch, one of the founders of quantum computing, embraces that paradox. He argues that the many worlds interpretation isn't fantasy. It's the only logical reading of quantum mechanics that doesn't require magical collapses. To him, each branch is as real as the next. Our existence just tunnels through one. It means your failures aren't erased. They're realized elsewhere. But so are your triumphs. Critics, though, see it differently. Physicist Sabine Hossenfelder calls many worlds a wasteful hypothesis. Infinite universes just to explain what we can already model with a single one. Others call it metaphysical overkill, saying it multiplies entities without evidence. They ask, if no branch can communicate with another, how could the theory ever be tested? But maybe the problem isn't testability. Maybe the problem is that we keep assuming reality is supposed to be one thing. Think of consciousness not as a location, but as a filter, a tuning dial among infinite frequencies of existence. What you call you might just be the frequency that aligns coherently long enough to produce the illusion of continuity. In other words, the many worlds aren't elsewhere. They're superimposed, layered right here, like countless radio stations broadcasting through the same space, never interfering because they're tuned to different wavelengths. That's not just poetic. Quantum decoherence literally separates realities by phase, a difference in their quantum rhythm. And if that rhythm could ever be altered even slightly, who's to say the boundaries between worlds couldn't blur? That idea is what drives the next wave of experiments. Because a few physicists are no longer just asking if many worlds exist. They're asking if there's a way to make them touch. And if they could, the consequences wouldn't just prove infinite realities. They'd merge them. The future of this question isn't just philosophical anymore. We're now building machines that operate on the same principles that supposedly generate the multiverse: superposition, entanglement, and interference. Quantum computers already blur the line between possibilities and realities. When a quantum processor performs a calculation, it doesn't follow one path. It explores many simultaneously. The result we read is the interference pattern of all those parallel computations collapsing into one answer. That means the next generation of quantum technology isn't just using probability, it's using the structure of the multiverse itself as hardware. Some researchers like David Deutsch and Chiara Marletto at Oxford go even further. They argue that quantum computation may literally draw computational power from other branches of reality. If that's true, then each successful computation we run might already be an experiment in cross-world interaction, tiny, precise, and happening millions of times per second. Now imagine scaling that up. Future quantum networks could one day manipulate interference between branches, not just within them. A subtle shift in a particle's phase might reveal information from an adjacent quantum state, a kind of echo from another version of reality. That's not science fiction. Physicists are already testing the boundaries of interference in delayed choice and entangled photon experiments, searching for signs that outcomes depend on measurements made after they occur. If those experiments succeed, it would mean something extraordinary. The universe may be aware of its own alternatives. Think about the possibilities that unlock. A civilization advanced enough could use controlled decoherence to send information across branches, messages between worlds. Medicine, computation, even consciousness research would transform. We might be able to see variations of history, not as fiction, but as neighboring threads of possibility. But there's a darker implication too. If our world can influence others, even slightly, then every experiment, every observation, every human act becomes a ripple through the entire structure of reality. Every discovery could alter not just this universe, but an infinity of them. So here's the question that hangs over the next century of science like an unsolved riddle. If we learn to reach across realities, how do we know which one will pull back? Let's pull this out of physics labs and into the quiet space of your own thoughts. Because if the many worlds idea is true, it isn't just about particles. It's about you. Every time you make a decision, even the smallest one, reality forks. In one world, you stay silent. In another, you speak up. In one, you hesitate for 1 second longer, and the ripple never stops. It's overwhelming at first. You start to wonder if anything matters, if every version of you already exists somewhere. But maybe that's the wrong question. Maybe the power isn't in controlling which reality you end up in. It's in realizing that the version you experience is the one you commit to. Think of it like resonance. Out of all the infinite possibilities vibrating in the quantum field, your focus, your attention, determines which one becomes vivid, alive, yours. The physicist Erwin Schrödinger once described consciousness as the singular awareness that unites multiple possibilities into one experienced world. That means you're not lost in infinity. You're anchoring one reality into coherence simply by living it. That flips the fear on its head. Instead of being meaningless, your choices become the mechanism by which the universe differentiates itself. Without your decision, those branches remain only potential. You make them real. And maybe that's what consciousness truly is. Not a passenger inside the multiverse, but the multiverse expressing itself through choice. Each act of attention is the universe watching itself from a specific angle. Each emotion, each regret, each love, a signature pattern that no other branch duplicates perfectly. So even in an ocean of infinite yous, there's something irreplaceable about this one, because only this version of you is aware of this exact sequence of moments, right now, hearing these words, in this slice of reality. That's your uniqueness, the awareness that collapses infinity into one story. But here's a thought that lingers like an echo through all of quantum theory. If consciousness can anchor a world, could it ever shift to another? And if it could, what would happen if you realized one day that you already have? So here we are, back in one version of an infinite reality. You're sitting where you are, breathing in air that, in countless other worlds, might never have existed. The light around you has bounced off atoms that could have behaved differently in another branch, but didn't here. And that tiny difference made this exact moment possible. It's strange, isn't it? We spend our lives trying to find the right path, the correct version of ourselves, as if we could ever step outside and check how the other stories turned out. But if infinite realities truly exist, then maybe the goal was never to choose the best one. Maybe it was to inhabit the one we're in completely. Because in a universe where everything happens, presence becomes the rarest form of existence. Not the multiverse out there, but the one you touch with your awareness right now. That's the frontier science can't yet measure. How consciousness turns possibility into experience. And maybe, just maybe, that's the most extraordinary kind of proof there is. That you are here, aware, participating in a universe that's constantly branching, but somehow still feels like one life. So as you leave this moment and step into the next, remember, there may be infinite versions of you, but only this one gets to know it. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.